This lesson is going to cover permutations and combinations. So lesson 5.5, our learning target is students will be able to distinguish between and apply what we call permutations and combinations. Okay, so we're going to talk about and distinguish between the two and then practice calculating them today, and we're going to introduce some new notation known as a factorial. So I'm going to go through this and talk to you about how to calculate it by hand. At the very end, I'll show you the calculator does have each of these functions, but I just want you to practice with the calculations by hand so that you get the hang of this kind of new animal called a factorial. So first of all, let's talk about the number of ways to count objects. So this is what we're talking about when we talk about permutations and combinations. It says when you need to count the number of ways that objects can be chosen out of a group, then the problem you are dealing with is either a permutation or a combination. So what's the difference? A combination, if we're just looking at that term, can be defined as a method of selecting items from a collection such that the order of the selections does not matter. Now, when we say order doesn't matter, that means we're just grabbing a clump of them. Okay, the order within the group doesn't matter, or the assignments within the group don't matter. In other words, it says one set of items containing elements A, B, C is considered to be the same as B, C, A. It's just a clump. They joined the group. That's one combination. A permutation, on the other hand, is a method of selecting items from a collection such that the order of the selections does matter, or the assignments specifically do matter. In other words, one set of the items containing elements A, B, C is not considered to be the same as a set written as B, C, A. Okay, so just as kind of an example, it says, suppose that a group of 10 runners is racing. The first 3 runners to finish in order are Chelsea, Chris, and Katie. This is different than them finishing Chris, Katie, and then Chelsea, especially to Chelsea. Though they are the same 3 people, changing the order gives them different outcomes for the race. So if it's just a combination and we want these 3 to score in the top 3, great. If it's a permutation, then we care that they finish in this specific order. Okay? Or they're assigned a specific role within the group. So let me show you just kind of an example based off of these shapes. So here we have a square, a triangle, and a circle, so labeled S, T, and C. It says list the number of combinations. So the only way to really combine these 3 is to create a group of 3 shapes. That would be like STC. Now that's the same group no matter what order I write them in. They're still the same 3 shapes. If we were talking permutation, then ordering them would make a different group. So STC would be different than SCT. If I put CTS, that would be different than CST. So every group that I make, or if I put the triangle first, those would be different, what we call permutations, because we're ordering them in different ways. Okay, so in this case, there would only be one combination, but notice there's 1, 2, 3, 4, 5, 6 different permutations. So if we were given like 5 shapes down here, so we've got all 5 off to the side, a square, a heart, triangle, an octagon, and a circle. Again, if I only have one shape, I can only make one combination, right? There's just going to be one shape sitting there, and really there's no other way to permute or order that if there's only one shape. So there's only one permutation as well. If there's 2 shapes, so say the square and the heart, I can either just combine them to make a group, so one combination, and I can put the square first and then the heart, or I can put the heart and then the square. So there's really only 2 ways to permute them in different orders. The 3 shapes is the one that we just did up here, so there was one combination, and there was, again, 6 permutations. And as we can continue to go, what you're going to do is you're going to find that the number of combinations, if we're just making one group, is just going to create that group of shapes specifically here. Now, combinations is not always 1, but it just matters if we only have that many shapes and we're combining them. Permutations, however, is going to change, and what you'll do is you'll find that every time we put, say, like this S in this front, and then we reorder the others, right? S in front, reorder the others, and we kind of work our way down there. Every time there were 3 possible in that first spot, that made 2 possible in the second spot, and then the last one had to go in that third spot. Same thing happens if there's 4 shapes. We could start each permutation with a different shape, and then there would be 3 possible to go in that next spot, 2 possible to go in the next spot, and then that last one has to go in the last spot. So 4 times 3 is 12, times 2 is 24, so there's actually 24 permutations if we had 4 shapes. And we could use that same logic if there's 5. So again, 5 in that first spot, 4 in the second spot, 3 options for the next spot, 2 for the next spot, which leaves the last shape in the last spot. If we multiply that all together, we get 20 times 3. So 60 times 2 is 120. So you'll notice permutations, definitely more of them because every order changes the set. Now, permutations and combinations, we use what we call, again, as I mentioned earlier, a factorial. Okay, a factorial is symbolized by an exclamation point, which is kind of crazy to see an exclamation point in mathematics. When calculating permutations and combinations, that factorial shows up. So let's talk about what a factorial is so that we can use it in our formulas. So first of all, the definition of a factorial is this right here. Now this might look crazy, but essentially it's what we were talking about just previously to count the permutations. If you have n, or a number, and then a factorial, an exclamation point written after it, what that means is it's just that number times 1 less, times 1 less, times 1 less, forever and ever, until you get all the way down to it just multiplying by 1. So for example, looking back up here, 5 factorial, I'm going to write this off to the side, would by definition be 5, the number in and of itself, times 1 less, times 1 less, times 1 less, until you get all the way to 1. So 5 times 4 times 3 times 2 times 1. So instead of having to write that all out, we just write this as 5 factorial. So let's talk about how to simplify that. Again, jumping down here, if I calculate the following factorial expressions, I'm going to have 7 factorial. That's the same thing as 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, again, your calculator can do this. I understand that, but I would practice it a little bit by hand just so that you're getting more familiar with what it looks like. I'm going to write the instructions for the calculator here so that you have them. If you want to use the calculator, you push the math button, and I'll show you this a little bit later. You'll go over to probability, and then number 4 on that list is a factorial. So again, you can do that if you want to check some of your answers. So if you multiply all of this in your calculator, you'll get 5,040 on this one. Okay. Jumping down to B, this is 4 factorial by 0, or divided by 0 factorial. Another way to write that is 4 factorial over 0 factorial. If you look up at the definition of factorial, 0 factorial is always equal to 1. So this is really on the top 4, right, times 3 times 2 times 1, because 4 factorial goes all the way down, over 0 factorial, which is just 1. So this is really just 4 times 3, which is 12, times 2, which is 24, times 1 is just 24. So 24 over 1, or we can just write this as 24. So how do I simplify it if it's a big crazy number like this? Even your calculator has issues with these ones. What we do is, again, we write them as a fraction. So we have 95 factorial divided by 93 factorial. Now remember, a factorial represents that number and every number less than that in their product. So if I have 95 times 94 times 93, and you're like, oh, this is going to go on forever, I could stop at 93 factorial. And then if I do that divided by 93 factorial, what I want you to realize is that 93 and 92 and 91 and 90, all of those would actually be rewritten here, 93, 92, 91, and they would actually cancel out because they're multiplication division. So really, 93 factorial will cancel with all the other 93 factorial on the bottom, leaving only 95 times 94 that we need to do in the calculator, which is 8,930. So again, I generally will take the biggest number and start to write out the factorial until I get to the factorial that matches the denominator or numerator if you're doing it reciprocal. So let's kind of use this idea as we look at this one right here. This is more like our permutation and combination formula. So we've got 5 factorial over 5 minus 3 factorial. So again, the 5 minus 3 is in parentheses, so that's 5 factorial over. 5 minus 3 is 2, so that would be 2 factorial. So again, this would be like 5 times 4 times 3 times, and I could stop at 2 factorial just to kind of show you what we did last time. And on the bottom we had 2 factorial. So remember that 2 factorial has all the same factors involved as the 2 factorial there. So this is really just 5 times 4, which is 20, times 3, which would leave us with 60. Same idea on the bottom here, but you have 2 pieces. So this is going to be like 6 factorial over 2 factorial. And then we have 6 minus 2 factorial, which is 4 factorial. Now I didn't need to put that in parentheses, just showing you that that's where that came from. So again, if I look at the numerator, I have a 6 factorial. On the bottom, I have 2 factorial and 4 factorial. This one's bigger. So if I get this one all the way down to the 4 factorial, I can do that and simplify. So 6 times 5 times 4, I would probably stop there. And then that 4 factorial from the bottom I know is going to be able to cancel. Now don't forget you also have that other 2 factorial on the bottom, so that's just, remember, 2 times 1. So essentially we've got 30 on top divided by the 2 on the bottom, because 2 times 1 is 2, which leaves us with 15. Okay, so let's practice this a little bit. Here's our formal definition of permutation, where order is important. The number of ways choosing R objects from n distinct objects. So notice here the notation and the way it's written. There's different ways to write combinations and permutations. We're going to stick with this one because it's the one similar to your calculator. This, again, n distinct objects is your total that you're choosing from or ordering. This is your total. R is the number that you're choosing or ordering, rearranging out of the total. Okay, so whatever that total is, we do n factorial on the top, and then we divide it by n minus r factorial. And again, a permutation is read as n things permuted r at a time. Okay, so r is that smaller group that we're permuting out of the total n. So for example, 8 people serve on a committee. In how many different ways can a chairperson, a recorder, and a treasurer be chosen from the committee members? Now this is a permutation because everyone in the group is giving a very specific assignment versus just a clump of leaders to go serve on a committee. Okay, so what we would do is we would say, well, what is the total? Well, there's 8 people serving on the committee, so that's going to be my n value. And then I'm going to permute 3 of them because I need to fill 3 positions, a chairperson, a recorder, and a treasurer. So if I'm plugging this into the formula, I do n factorial, so my n is that 8 over n minus r factorial, so 8 minus 3 factorial. And then it's just a matter of simplifying like we just did on the previous page. So this is going to be 8 factorial over 5 factorial. So I'm going to simplify this down, 8 times 7 times 6 until I get to 5 factorial, and then I'll stop there because that's the same as the bottom. So those will go ahead and simplify. From there, I just have to do 8 times 7 and then multiply that by 6, and I get 336 different ways they could assign those people. Now on the bottom one, or the next example, this says Drea and Brian are auditioning for a part in the school play. There are 15 people auditioning, and the order of their auditions is chosen at random. Find the probability that Drea auditions last and Brian auditions second to last. Now, if we're looking at this, one way to think about it is you need to find the number of ways that they can be assigned to those specific spots over the total number of ways to order the 15 people, because it's probability. So this is like the total number of ways to order 15 people. Sorry if that's hard to read. And then on top would be the number of ways to order them with those guys in those specific spots being last. So total, we're just taking all 15 people and we're ordering them in 15 different ways. And then on the top, what I want you to think about is anytime you're filling positions, so this is going to be crazy, but I'm going to write out little 15 marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm putting 15 people in order. The thing is if they tell me that Drea has to be last, then I fill that position, and there's only one way to fill that position because she has to go there. And Brian has to be second to last, then I put him here in this position. Now that those two are filled, then the other 13 positions are the only ones that I need to permute. So this would be 13 over 13. So as we go through this, we could go ahead and calculate this. And the more you do the permutations, you'll notice, and I'm going to write this out, it's going to look a little crazy, but if I use that formula, that would be like 13 factorial is my n, right? And then n minus r, so if you think about it, it's 13 minus 13. Anytime you have a certain number of items and you permute that same number, it just becomes like this is 13 factorial over 0 factorial, which is 1. So it's really just 13 factorial on the top. Same thing on the bottom. If I have 15 factorial and I put in my n minus r, then that just becomes 0 factorial on the bottom. So essentially it's 15 over 1. So we're just going to have 15 factorial. So if I'm simplifying this, again, now 15 is the bigger number. So I would go 15 times 14 times 13 factorial and leave that 13 factorial on top so that that can simplify and cancel in that same way. Now you still need a numerator. So 1 is our placeholder, and then 15 times 14 would be 120. So that's just one way to use permutations and combinations, well, permutations specifically here, to calculate probability. Let's talk about combinations. So the formal definition of combinations, where order is not important, you're just grabbing a group from a larger group. So the number of ways to choose R objects from n distinct objects. So again, n is the total and R is the number that you're choosing. You'll notice the formula looks very similar. We have n choose R, and we have n factorial, but because order doesn't matter, we divide out more of the possibilities there. So we've got r factorial times n minus r factorial. Sometimes you'll see the combinations written in this way. Again, we're going to write them in this form just this year, and we read this as n choose r. Okay. So let's look at a couple examples. It says you're listening to music. You have time to hear only 3 songs from your playlist of 16 songs. How many combinations of 3 songs are possible? Well, you look at your total. So you have 16 songs total. So that's our n value. And you're going to choose 3 of them. And you don't really care what order they're in, but how many combinations of just 3 songs could we choose? So again, we go to our formula. Our formula says n factorial, so n is the 16, so we put 16 factorial over r factorial up here. So that's 3 factorial times n minus r factorial, so 16 minus 3 factorial. So in this case, we've got 16 factorial on top. We've got 3 factorial here, and 16 minus 3 is 13 factorial. So if I'm simplifying, again, I usually look at the 2 biggest, one from the top, one from the bottom. I would start to simplify this down. 16 times 15 times 14 times 13 factorial all over, and we want to leave that 13 factorial there to cancel. And then I'm going to write out the 3 times 2 times 1. Now, crazy thing is, these factors, you can actually simplify. So like, if 3 goes into 15, I could actually simplify this, and this could become a 5, and the 2 could go into 14, and that could become a 7, and then I would have nothing left on the bottom, and I could just multiply 16 times 5 times 7. You can absolutely do that. If that's more confusing to you to keep track of factors, then you don't need to do that, and you can just multiply the top, multiply the bottom, and then do that division. Essentially, that'd be 560. Okay, let's talk about finding permutations or combinations here. With the calculator, I just want to clarify that it can do that. On your assignment, you're going to be asked to show work and working through the formula just to practice that. But essentially here, let's look at the calculator. I should have pulled it up already. So here's our calculator. And actually, I don't know if your calculator does that, or my calculator here does that. But if you push this math button here on the left, and then you go over to the probability menu, you'll notice there's a factorial there. There's NPR, NCR. So we could choose one of those. The one on it said 9P9. So I'm going to go to the second one, and I can put in 9, and then I can go over and put in 9. And notice that will do that calculation for me. So I would know that it would be 362,880. Or again, I go to math, over to probability, down to the C for choose, and the next one on your notes is 7 choose 3, so I could put 7 choose 3. So those will calculate it for me, and I can come in here and I can just identify that would be 362,880. Now again, I understand the calculator does that. I just would definitely practice using the factorial language so that you're comfortable with it moving forward and what it means. Okay. That'll be the end of this video. I will create one more video that just shows an additional counting technique as well as maybe a couple from the homework to give you